Okay, so what we're going to be starting off with today is we're going to be graphing quadratics. So quadratics are what we've been learning a lot about for the last few weeks. We talk about factoring, doing quadratic equations, completing the square and all of that. So we're just going to continue on, and this time we're going to graph them. I did send all of you guys an email, I believe last night, telling you guys to bring some graph paper or something to graph on. So hopefully you have that with you because you're really going to need it for this class. So here we're going to start off with just the first problem. It's a very simple one. It is graph the equation y equals x squared by first plotting the points and then graphing it out and then answer these two questions at the end. This is a relatively quick one, so I'll give you guys 3 minutes to do it. Okay, it's been 3 minutes, and since we have a lot of problems today, I'm not going to be calling on anyone. I'm just going to be explaining them out. So the first one was relatively simple. So if you plot the points, you'll get these points, and then you can see it's symmetrical along the y-axis, and this half is symmetrical to this half. And the reason that is because what the x squared does is it takes this number and multiplies it by itself. So regardless of if it's negative or positive, you'll get the same answer if the absolute value of that number is the same. So that's why that does that. So now we're going to move on to the next problem. This one's a little more difficult because I'm asking you to graph 3 different equations. So I want all of you to graph these out. Just don't do it in your head, but graph every single one of these out. and write out your points, and then tell me what effect these coefficients have on the quadratic. So it's 5, this 5, and this negative 1/5, and this positive 1/5. And then I want you to explain to me what the effect is and then type it in the chat so I can take a look at it. Okay, I think that's enough time for this problem. So we're gonna discuss this. So these are what those three equations look like. So 5x squared looks like this, x squared over 5 like that, negative x squared over 5 like that. And so this is what they look like when you put them all on top of each other. So essentially what that number in the front does is it determines how steep and how narrow the parabola is going to be. And this makes sense because if you think about it, your x squared is like this. And what your 5x squared does is it takes that x value and then multiplies it by 5. So whereas when x is 1, y is 1 for this equation, when x is 1, y will be 5 for this equation because of that coefficient. And it's the same thing here, except here you're divided by 5. So when x is 1, it'll only be 1/5 here. So that's essentially all you're doing in this scenario. So and then all that negative does is that I don't have it here, but it just flips it upside down. So that's all the negative does. So here's a pretty long problem for you guys. So it says graph each of these equations. And then it's the same for part B as well. So I just want you guys to try to do this. It'll probably take you 10 minutes to graph all of these. So take your time, and then in 10 minutes, we'll come back and I'll explain it. Okay, I think that's enough time for that problem. So we're going to go over it now. So for part A, all we did is, if we go back, we can see all we did is we changed this inside number here. So when we look at these graphs, what we see is that when we change that inside number, the graph moves left and right. So when that number gets positive and then more positive, it keeps going more, it keeps going to the left. When it gets negative, it's on the positive side, and then when it gets more negative, it keeps moving to the positive side. And so essentially that's all this does when you change that inside number letter H. And then when you change this outside number here, what happens is that it just increases or decreases its height in the graph basically. And this is pretty obvious because after we do all this, we're just adding or subtracting a constant number. So we would just add 3, we move the whole thing up by 3, subtract 2, move the whole thing down by 2. 5 is the same thing. So when we change this k value, it changes it from moving up and down, and this h value changes it from moving left to right. So now here is another problem where you just have to graph this equation, but the trick here is that you have to complete the square on the right side so you're able to write it in this form again. So this might take you time, but since it's only one equation, I'll give you guys 6 minutes to try to do this problem, and then I'll explain it. Okay, it's been 6 minutes, so we're gonna talk about this problem. So the answer is kind of brief here, but essentially if you do complete the square, you'll get your answer. And then what we do with the graph is we realize after we complete the square that our vertex would actually be here at at positive 3/2 for x. So then all we have to do is we plug that value in here, so we can figure out exactly what the negative y value is for the vertex. So that's all there is to this problem. So here's another one, 14.5. So again, I'm going to give you guys a lot of practice. So I want you guys to graph this thing again. And then I want you to complete the square on the right side, just like the last problem. And then be able to transform it into this form. And then figure out what these three letters are and then graph that equation. So I know this might still be difficult for some of you guys, so I'm going to give you 6 minutes again. And then even if you're struggling, I'll go through the answer more in depth than the last question. So you should be able to do future problems like this. Okay, it's been 6 minutes. I'm going to explain this problem now. So first we have to complete the square here. So essentially what we first did is we multiplied the whole equation, we divided the whole equation by 3 to make sure this coefficient is 1 because that's important to complete the square. And then we figured out that we needed to add 4 to this equation in order to make this a square binomial, which means we add 4 to the other side of the equation here. And then this whole thing, this part collapses down to x plus 2 quantity squared plus 5/3. And then so we have negative y over 3 plus 4 equals x plus 2 quantity squared plus 5/3. So then what we do is we subtract this 4 onto the other side, and then we multiply the whole equation by negative 3. So then what happens is we get y equals negative 3, x plus 2 quantity squared plus 7. So all we did was we did a little bit of rearranging, completed the square, did a lot more rearranging, and then we were able to get this equation. And just remember, if you don't understand the exact algebra here, since I'm going pretty fast, you'll be able to look at it later on when I send out these slides in an email. And then there's another method here, which is where you just factor, instead of dividing the whole thing by negative 3, you factor out the negative 3 here. And then you add 4 inside here, and then you add the negative 3 times 4. You add the negative 3 times 4, and then after that you can combine these two terms in order to get your whole thing, to get your square binomial. And then you have the minus 5 on the end here like this. So this is what your whole thing equals, and then you multiplied that over on this side too. And then you take your x squared plus 4, you simplify it to x plus 2 quantity squared. Then you expand this out. So y minus 12 equals negative 3 x plus 2 squared minus 5. And then what you do is you add that 12 onto this side, so you get the y by itself, and you get the same equation. This is just a much longer way of doing it, but I wanted to show it to you guys in case some of you did it this way. So now also when we eventually do graph this whole thing out, what we realize is our graph is downwards because of this negative in this equation, which means it points downwards like that. So, and then after this, since from our last time, if you remember, it was x plus 2 quantity squared here, which means when x is negative 2, that should be the highest point in the equation because x is 0. And then that's where our vertex is. And then we just choose a few points on both sides to get the parabola. So here is another parabola problem. You guys are going to be pretty much doing graphing for this whole session. So I want you to graph this one and then complete the square again like the last problem and graph it. But here's the important thing. Realize that here the x is isolated and the y squared and the y are on the other side. So take that into account when you graph it because this graph is going to look very different from the other ones. I'll give you guys again, maybe I'll give you 7 or 8 minutes on this because of the extra complexity with the different variables. So till 7:44 is how long I'll give you to do it. Okay, so I'm going to go over this problem now. So essentially we just complete the square again. So we have to multiply both sides by 2 to get rid of that fraction and make the y squared have a coefficient of 1. Then we find that number that will give us a square binomial. So we add that to both sides. Find that square binomial and then have this plus 2 at the end. And then after that, what we do is we subtract this 9 over. So we get negative 7 over here. And then all we do is divide it by 2 to make sure the x is by itself. So this should be what your final equation is. And then with that, we just graph this equation out right here. Since this one is x equals a whole bunch of y terms, it actually faces sideways. So with positive y, it faces out to the right. With negative y, it faces the other way. And then with y plus 3, so that means that when x equals negative 3, that's where you'll find your vertex. I mean, when y equals negative 3, that's where you'll find your vertex, which is exactly right here, which means it will be symmetrical along this line. So when you plug in all your other coordinates, you'll be getting this parabola that looks like this. So that's essentially all it is. It just tilts it around by 90 degrees. So here's another one, parabola. This is problem number 7. And then a parabola has this vertex. So the vertex is that point, which is the most left, right. So this point. So the point that's essentially kind of at the bottom or the furthest left or right. And then that's this vertex, and it has a horizontal axis of symmetry, and it passes through this point here. So with these 3 clues, try to figure out this equation. It might be a little hard, but I'll give you maybe 4 minutes on this problem since we're running low on time. Okay, so now we're going to go through this problem. So this one might be a little tricky. So essentially what we have to do is, since we know it's horizontal, that means it has to be x equals y squared something something, because if it's symmetry like this, that means it has to open this way or this way, which means it's x equals something. And we know the vertex is 4, -3, so we know that h is 4, with the h is 4, k is -3, so we can plug those into our equation right away. And then after that, we can plug in this point into our equation, and then we can figure out what a is, which in this case is 1/9. That's all there is to this problem. So here's the last parabola problem, I believe. Yep. So I think I'll give you guys, again, 5 minutes on this problem, and then we're going to keep moving on since we have a lot of other problems to do. So this is a parabola that passes through these 3 points and has its axis of symmetry parallel to the y-axis, which means it's this way, which means the equation should be y equals something. So do these 3 problems. I'll give you 5 minutes or so to do it, and then we'll go over it. Okay, we're going to go through this problem now. So well, we know immediately that this can't be the answer, because I just told you it has to be y equals something since it's parallel to the y-axis. So we got that part down. Then after that, this one might have been a little tricky for some of you guys. So the trick here is to not use this form, but try to use this form instead, where it's x squared plus x plus c. So essentially all you do is you take those 3 points, you make 3 equations, system of equations, and you'll get your answer. So some of you might not have been able to connect those dots, which is understandable because it's a pretty tough problem, but that's how you go about doing that problem. So this is 14.9. Now we're moving on to circles. So I want you guys to try to do all 5 of these parts, and then I'm going to explain this problem. All of these, this shouldn't take that long, so I'll give you 5 minutes for this problem. Okay, we're going to go over this problem now. So it says the first part is graph several points that are 4 units away from the point 2, -3.
So we could take this point, this point, this point, and this point all here, and those would all work for us because there would be all 4 units away. Those are the easiest ones. And then after that, what shape consists of all 4 points? It would be a circle. And then suppose the points are 4 units away, use a distance formula to write an equation. So when we write our distance formula, it would look something like this because it would be x squared plus y squared square root equals the radius. And in this case, we have these two extra modifiers because of exactly where this point is. And if you square both sides, you'll get this equation. So this is essentially the equation of a circle. It'll always follow this pattern. So this is something you should try to look out for. This is what we call the standard form. So it's essentially x squared plus y squared equals radius squared. And these extra modifiers here tell you where the center of the circle is. Since this is -2, when x equals 2 and y equals -3, these both equal 0, which means that's the center, and which we can see here at 2, -3, that's the center of the circle. That's how you determine that. This is the exact equation with your h's and k's, and then that's where the center would be. So that's all that there is to this problem. Here we're going to move on. So you see this equation, use a distance formula, and explain why this equation would be a circle. Then figure out what the center of the circle is and then what the radius is. This is a pretty quick problem. I'll give you guys only 4 minutes on this. Okay, I'm going to go through and explain this problem now. So with the distance formula, what you realize is that the standard form for a circle formula is just a squared version. So if you square root it, you can see that this is essentially the distance formula, which is how you know it is. And then what was the last part? What was the center of the circle? So with this, I remember how I told you about how it's just this number and this number. So it'd be at x equals 7, y equals 4, which is exactly what we have right here. And then also this is r squared on this side. So if you square root that, you'll get 5, which is then the radius. So that's all that there is to that problem. Here's another one. Take your time, try to graph this one. This one might be a little more difficult. So take your time and then find the center and the radius for this. Okay, we're going to go through this problem now. So this one might have been a little more difficult. So what we have to do with this problem is we have to do two complete the squares, and then we have to add both those parts to this side. So for this first part with x squared plus 2x, we need to add 1. For this part, y squared minus 3y, we need to add negative 3 halves squared. And we put those on the other side as well. And then what happens is when we do this is this turns into x plus 1 quantity squared. This turns into y minus 3 halves quantity squared. And then when we add all this together, it becomes 31 over 2. So essentially, if we square root this, we get a radius, which is shown here. This would be a radius because we have to square root this whole thing. And then the center would be at -1 and 1.5, because in this previous one, we can see -1 will make this 0, 1.5 will make this 0. So that's how we know that's the center. And then that's the radius for the circle. So we have 3 more problems to go. So since we have 18 minutes left, I'll give you guys 6 minutes on this problem. So this is a graph in this form. Ax squared plus bx plus ay squared plus cy equals d. And now you need to figure out if a, b, c, and d are constants and a is not equal to 0, will it always be a circle? So if it always is, give me a few examples and then explain that. And then if it's not, give me a few counterexamples. Okay, we're gonna go through this problem now. So in this equation, we have ax squared plus bx plus ay squared plus cy equals d. And we say a is not equal to 0. And we're essentially asking, will this always make a circle? So the answer is actually no. So as long as d is positive, you'll always get a circle. However, if d is negative, there's no way you can get two squareds added together to become negative. So this equation just can't exist unless we start talking about imaginary numbers in this case. However, with this problem, and then when it's 0, you get what we refer to as a degenerate circle, which is actually just 1 point, because these both have to equal 0, which means there's only 1 point that'll ever satisfy this equation. So that's how that one works. So it's just based on the sign associated with the side without the variables. So here's the second to last problem, I believe. So I'm going to give you guys 6 minutes on this problem again, too. Just skip part B since it's referring to these other problems I don't have up on the screen. Just do just do part A. I'll give you 5 minutes to do this problem. Okay, this problem probably didn't take you guys the whole time, so I'm just going to end it early and then explain this one out. So we have our standard form here, and then we have, if we expand it out, we get x squared plus some quantity bx plus y squared plus cy. And this h squared and k squared are just constants, so they would just subtract over and create this d value here. Luckily, it's pretty easy to find the d value because the circle passes through this point 0, 0, and the equation must be satisfied when 0, 0, which means d also has to equal 0. So in that case, you can put in B, C, and substitute them in, and then since we know D has to be 0, we can solve it out. And then we get our system of equations. We solve the system of equations. We figured out B is -6, C is -8. We can put those in, then we do our complete the square, and then we can figure out what our answer is. And then this is the last problem, I believe, for today. So I want you guys to graph this equation, this and this equation, and see if they intersect. Also, there's an algebraic way to do this. So if you want to challenge yourself, try to figure it out algebraically. And then I'll give you 5 minutes to try this problem. Okay, so we're going to end this problem right here. So I'm going to explain it to you quickly. So this again is a system of equations problem, because if you think about it, wherever these two intersect, that means the x and the y should be the same values and they should satisfy both equations. So when we do this, what we realize is we can add the y to this side. So we get x equals 7 plus y. So now we know what x equals. So we just substitute in x. We simplify this all the way down. And then we can expand y plus 7 squared, 4y plus 7. We collect all the terms together and we get this formula right here. And then with that formula, we divide it by 2, we get this formula, and then we can actually factor this formula into y plus 3, y plus 8. So this means, you know, when it's y equals -3 and -8, they intersect, and then when you plug them back into the equation, you can figure out those x values. So you get 4, -3, -1, -8. Those are where they intersect, and if you actually graph this problem out, you would have gotten the same answers. So graphing it is one way, and then doing it this is another way. So I believe that's the last problem. And then a lot of you asked about office hours, and only I think 2 people showed up last time. So I think I made a mistake. So technically they would be on Sundays, 8 to 9 a.m. China Standard Time. These are the times on Saturdays. Here's the links and passcodes. So if you guys have any questions, I encourage you to come to those, because a lot of, like, I think 10 of you or something asked for them, but only 2 of you showed up, which means the rest of you didn't show up. So if you have questions, I encourage you to come to these, or else it'll be very difficult to learn the later topics in this class. So that's it for today. I hope you all have a great rest of your day, great rest of your evening or morning, depending on where you are. So bye.